we hit something, basically, then what we're going to need to do is grab the position that we hit. Wish somebody needed me. Oh well. In this stage, we're going to load a map from an external file. We'll then draw a top-down view of the map and learn about state machines. Here's the contents of the map file. We can load the file and display its contents. Now let's deal with those lines. The size line indicates the XY size of the map. When we see it, let's allocate a NumPy array for our map. We've chosen to store each entry as an 8-bit unsigned integer. In general, the less memory we use for elements, the faster memory access will be. The map line indicates the beginning of the map section. When we see it, we'll jump into a map loading function. We essentially read the map one horizontal line at a time. The end tag signals the end of the map section. Now let's render the map. The renderer system can now take the map data in its constructor. This is completely okay because NumPy arrays are lightweight data references. Now in the initializer we can calculate the width and height of each grid square to stretch the map to the size of the screen. When it comes to drawing all these grid squares, it will become a lot simpler if our draw rectangle function takes a top left corner and a size argument rather than a top left and a bottom right corner. Let's go ahead and adjust that. The rendering code will then become a lot simpler. Let's split the top-down and perspective views into two individual methods. Now onto the map. First of all, let's get that grid properly spaced. We can then define some new colors in the renderer's palette for the walls. And now finally we can draw the map. The basic idea is to loop through the map, draw any walls, and then finally draw the grid over the top. Our renderer currently has two modes. We can control this with a simple toggle. So here we're detecting the tab key and switching between modes. And this is fine, but it won't scale well, and it gives us an opportunity to examine a more elegant approach. State machines. Let's define a class for each draw mode. With the rendering behavior and state offloaded to helper classes, the renderer itself can now be made simpler. There are more elaborate abstractions we can use here, but they're not really worth it right now. And there we have it. We should now have a handy map view which we can toggle with the tab key. In the next video, we're going to add a player object and start moving them around. It may surprise you that we're not really touching 3D yet, but the truth is debugging 3D applications is hard and we'll have a much better time if the core game features are solid first. Anyway, hope to see you then. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.